A very good morning to Sir Abdullah and my fellow friends. Today my group is going to be presenting on the Basell Spherilene technology for Lldpe and Hdpe production. So this is my group members. First is Dayang, Willcynnea, me myself, Maanisha, Sinthia, and Willcynnea N. The Spherilene technology is an advanced gas-phase polymerization process for polyethylene. So that's divided by four: high-density polyethylene, medium-density polyethylene, linear low-density polyethylene, very low density polyethylene. So what's the purpose of this Spherilene technology? Is provide flexibility, high quality product grades, and efficient production of polyethylene with different molecular structure like isomer. So the technology type is a two reactor gas phase pressurized polymerization system. It means the first reactor is contain two reactor. The first reactor produce homopolymer and the second one produce copper polymer, means like add ethylenes or rubber phase. So the catalyst used is Ziegler-Natta titanium in the reactor. The process feature uses two reactors in a series, allowing precise control over molecular weight distribution and co-monomer incorporation, which is such as polypropylene. The first reactor is the polypropylene homopolymer, which giving strength and stiffness. The second reactor is introduce ethylene or other co-monomers to form impact on a random copolymer. So the advantages is high flexibility in product switching, environmental friendly, consistent polymer quality, and safe operation with advanced control system. The application for the Basell Spherilene production for Ldpe and Hdpe is packaging films, pipes, agriculture films, bottle, toys, and containers.
Saya Willcynnea Hdpe dan sekarang saya akan menerangkan chemical reaction of polyethylene ataupun kita panggil polyethylene ni sebagai PE untuk singkatan lah. Jadi production of PE ni tadi dia bermula dari simple gas yang kita panggil ethylene ataupun dia punya molecular formula adalah C2H4. Jadi ethylene ni tadi dia adalah satu small molecule yang mengandungi double bond antara dua karbon atom tu tadi. Seterusnya, ethylene ni dia akan mengalami polymerization process. Jadi, polymerization process ni maksudnya adalah proses kimia di mana molekul-molekul yang kecil tu ataupun kita panggil molekul kecil tu tadi sebagai monomer, dia akan bergabung secara berulang untuk bentuk molekul yang sangat besar dan juga panjang, iaitu kita panggil polimer. Ingat molekul yang kecil tu tadi kita panggil monomer dan molekul yang besar dan panjang tu tadi kita panggil dia polimer. Jadi during polymerization process ni tadi, double bond tu dia akan broke lah, dan banyak ethylene molecules dia akan join together in a long chain. Okay? Jadi proses ni dia akan membentuk polyethylene ataupun kita panggil PE, dan di mana kita boleh tulis dia punya reaction tu sebagai open bracket dash CH2 dash CH2 dash close bracket the power of n lah, macam tu. Di mana maksudnya adalah meaning thousand of repeating units lah yang terjadi di sini. Seterusnya, proses ini juga kita panggil addition polymerization, sebab ethylene molecules ni dia add up without forming any byproducts. Dan seterusnya, dalam Spherilene proses ni, polymerization ni dia akan jadi dalam gas phase reactor menggunakan special catalyst. Catalyst yang kita guna di sini adalah Ziegler-Natta lah. Jadi catalyst ni dia control the molecular weight of polymer. Yang kedua adalah branching structure and density. which determines whether the product becomes LLDPE. LLDPE ni adalah liner low density polyethylene ataupun HDPE. Kita panggil high density polyethylene lah. Jadi HDPE ni dia has straight chains, tightly packed dan juga higher strength and density. Manakala LLDPE ni tadi has short side branches and more flexible and tough. Jadi in short lah, the polymerization of ethylene ni is the key chemical reaction that produces different types of polyethylene. Jadi PE ni dia digunakan dalam dari segi packaging, containers dan juga films. Itu saja daripada saya. Seterusnya saya akan serahkan kepada pembentang yang seterusnya untuk menerangkan proses description tentang Spherilene proses ni tadi. Thank you.
Hi everyone, my name is Sinthia Simon. Today I will be explaining the first part of the Spherilene process, focusing on the catalyst activation, feeding, and also the polymerization in the first reactor. In the Spherilene process, the production begins with catalyst activation. The catalyst used is a Ziegler-Natta catalyst made from titanium compounds supported on magnesium chloride combined with an aluminum alkyl co-catalyst. This type of catalyst works under low or medium pressure, allowing efficient polymerization and better control of the product properties. The catalyst and co-catalyst are mixed together in the activation unit, then carried into the first reactor using a light hydrocarbon carrier such as butane or propane. This carrier helps to distribute the catalyst evenly into the polymerization system. Each catalyst particle acts like a tiny microreactor. Polymerization starts right on its surface, forming small, spherical polymer grains. Next, the activated catalyst enters the first gas phase fluidized bed reactor. In this reactor, ethylene gas, a small amount of comonomer like butene or hexene, and hydrogen are continuously fed from the bottom. The gas flow keeps the polymer particle suspended, creating a fluidized bed that looks like boiling sand. This ensures even reaction and prevent the polymer from clumping. As ethylene gas and comonomer flow through the reactor, they react on the surface of the catalyst particles, forming polyethylene chain. Each catalyst particle acts as a tiny microreactor, and as the reaction continues, polymer powder grows around this particle. By adjusting the composition of the circulating gas, such as the amount of hydrogen or comonomer, we can control the molecular weight and density of the polymer being produced. At the top of reactor 1, the unreacted gases, mainly ethylene, comonomer, and hydrogen, leave the reactor along with some heat that is produced from the exothermic polymerization reaction. These gases then flow through a centrifugal compressor. The compressor keeps the gases moving continuously in a loop, maintaining a steady circulation throughout the reactor system. After compression, the gases pass through a cooler. The cooler removes the heat generated by the polymerization reaction because if the reactor gets too hot, the reaction rate would become unstable or polymer quality would change. Once the gases are cooled, they are sent back to the bottom of reactor 1. This continuous loop from the reactor, compressor, cooler to reactor keeps the process steady and efficient. When polymerization in reactor 1 is complete, the polymer powder, now partially formed, is discharged from the bottom of the reactor through a valve system into a low-pressure vessel. The unreacted gases are separated from the solid polymer powder. The gases are recycled back into the system through the same recirculation loop, while the solid polymer moves to the log hopper, which safely transfer the material to the second reactor. To summarize, in this part of spiraling process, the gas recirculation loop keeps the reactor temperature and pressure under control, while ethylene polymerization happens in the fluidized bed reactor. This step produces the initial polyethylene powder that will continue to develop in reactor 2. Thank you. Now I will pass to the next presenter to present about the next part.
So, I will be presenting about the second step, which is polymerization. After the polymerization that begins in reactor 1, the partial polymerized material will flow directly into reactor 2. Both reactors are connected in series to ensure a continuous gas phase process. And then the rector tool customize the polymer's final characteristic, which is density, molecular weight, distribution, and mechanical properties. So before it flow into the rector tool, the polymer will flow through the log hopper. It allows the activated catalyst to be transferred safely from the storage vessel into the gas phase reactor, which is reactor 2. This prevents pressure loss and ensure a controlled continuous feeding of catalyst into the reactor.
The polymer UN will send to the second gas phase reactor from the low copper system. Then it will transfer to the low pressure vessel. This reactor is independent gas composition, pressure, and temperature. The polymer N is sent to the second gas phase reactor from the low copper system. Then it will transfer to the low pressure vessel. Then, polymer contains traces of unreacted monomer and active catalyst. It enters stripping unit when steam is in intercurrent flow. Steam removes leftover monomer and hydrocarbon. It also deactivates catalyst. Stripped gas are recovered, dried, and recycled back to the process. After steam, polymer become wet. Wet polymer was sent to the nitrogen drying unit. Dry nitrogen gas will remove all the moisture from polymer. Nitrogen gas is recycled after drying.
Let me summarize the key points of the Spherilene process. This process is a flexible, efficient, and environmentally friendly method for producing polyethylene or PE. It allows the production of a wide range of polymer grades, from very low density polyethylene to high density polyethylene, by using Ziegler-Natta titanium catalyst. Overall, the Spherilene process is safe, clean, and cost effective. It also ensures consistent polymer quality, which makes it a reliable choice for industrial PE production. That's all from us. Thank you for listening.
That's all from us. Thank you.